Good afternoon and welcome to the Embedded Executive Podcast. My name is Rich Ness. I am the Executive Vice President of Open Systems Media and I lead the team for Embedded Computing Design. Here for this week's Embedded Executive Podcast, my guest this week is Steve Totosian, who is the Senior Vice President of Consumer IoT and Industrial MCUs. How you doing, Steve?
I'm doing great. Glad to be here.
Thank you. So you must be pretty good at this because you're a return guest, and we don't invite just anybody back for a second time. So it must have went pretty well the first time.
I think it did. I hope it did anyhow.
Well, honestly, it isn't what I think. It isn't what you think. It's what the readers tell us, and the readers were okay with all the things that we talked about. If I remember right, it was a pretty lively discussion that we had. So see if we can have another lively discussion. And I'm basing this around an announcement that I saw that you guys are making. Or have made actually, about some AI MCUs. Just very, very briefly, would you tell me what that announcement is, and then I'm going to challenge you on some stuff with respect to that.
Sure. So the announcement is we're building out our PSOC Edge portfolio and announced 3 series of devices within that family with varying ranges of compute, peripheral support, on-chip memory, and hardware machine learning enablement on these devices. So essentially neural net coprocessors.
Excellent. So you're likely aware that there's actually been a whole bunch of announcements that are similar in the last few weeks and in the next few weeks. People are rolling out AI CPUs, MCUs, GPUs, and I don't want to talk about the chips themselves just yet. I want to talk about the ecosystem because it seems to be that there are 2 very different paths the vendors are taking. One path is where they're either developing a lot of the software themselves or they're making acquisitions of companies who have that software, or they're leaving it open to either open source or just telling the community, just roll your own. Now, first, which camp is Infineon in? And then let's talk about why.
Yeah. So actually, we're in both camps, and the reason for that is we really believe
you're in both camps.
I will get to this in some detail here that really supports the answer. What we really want to do is we want to meet our customers, and we want to meet the market, and we want to meet the ecosystem where they are. So for customers who are already working with a partner, for example, we want to enable that and enable them to continue to work with that partner to get their software support as needed. For customers who are looking for something open source or from the community, we support that both with our I'll say deployments to the community, but also through other activities that build up that community software base. That all being said, Infineon did acquire Imagimob last May. Which offers a full end-to-end tool suite for machine learning model creation. That has now been integrated into our software ecosystem that we call Modus Toolbox here at Infineon. So we have done both, and we are in both camps. But I want to say something that is, I think, unique about how we're addressing this at Infineon, which is, first of all, we are delivering what we call ready models with Imagimob. So turnkey ready models that are, I'll say, already proven and delivered as is. So customers don't need to know anything really about machine learning. They don't need to have a data set, for example. They can pick up a model and for example, enable cost detection on their device. However, this tool chain from Imagimob that we've now integrated into Modus Toolbox is really open. So it, first of all, again, meet the developer where they are. If they have their data, they can import the data, label it there, prune it, create the model, optimize the model, and the output of that is C code. Okay. If they don't have data, we can support data collection. If they already have a model that's been optimized, they can bring it into Modus Toolbox and get it on the target device. So being able to allow developers to enter into this ML development flow where they are is also important for us. And then that, again, that output is very open and transparent in terms of C code that then, of course, targets Infineon devices through our tool chain.
Now, you say bring those models in. That's not as easy as it sounds. Artificial intelligence is not something that's easy.
So I don't mean to make it sound easy or simple for anyone, but what I will say is that that is what we are providing. So when customers have models of types that are supported through our tool chain, bringing them in is fairly straightforward.
Okay. Now, I'm of the opinion that you guys have a pretty good advantage, and I won't say it's an unfair advantage. I think it's a very fair advantage because you've earned it. PSOC has this community that's not. It's very different from some of the other communities that are out there. It's extremely loyal, and I think when you guys put these products out there, you get immediate buy-in from a very large group of people. Is what I'm saying accurate?
Uh, I hope that is the case too, and that is, I think, very much aligned with what we expect and what we're seeing. And we do have some great users and developers and a large community around our existing portfolio. And the capabilities that we bring as we expand our portfolio with these new PSOC Edge devices, I think will be super exciting for that community of developers to embrace as well.
Yeah, that was one of the things when you guys acquired Cypress. I was hoping you wouldn't. I hate to say screw up, but I was hoping you wouldn't screw it up, and you seem to have not screwed it up, bringing those people on board, from Cypress people to Infineon people.
Yeah, I think we've really embraced that. That's been a huge asset, frankly, for us, and not just to embrace it, but to nurture it into the future here.
Now, tell me about the 3 different devices that you've released.
So it's 3 different, actually, series of devices within the PSOC Edge family, and we call it E81, E83, and E84. And again, the scalability there is really around features and performance. So when we start at the E81, those are really for customers who really are looking to move up in MCU performance. So they've kind of hit the end of the road where they are today with their M33 class devices, or maybe even their M7s. And where is that next step, either in terms of just pure scalar performance or improved DSP performance? And those are 400 megahertz M55s, up to 4 megabytes of on-chip RAM, plus additional non-volatile RRAM on-chip as well. And then an M33 in a low power domain for kind of always-on sensing and monitoring. When customers would move to the E83 version of the device, there they'll get access to the Ethos U55 NPU paired with the M55, so really high performance ML support, as well as in the low power domain, a NN Lite, so a lightweight neural net processor that Infineon has developed specifically for again, these always on kind of sensor ML based applications. And then moving to the E84, it builds on the E83 by adding a 2.5D GPU. So here where applications have rich graphic display needs, customers would land in an E84 type product.
Does each one of these have its own development kit, or are you working with the same kit?
That's a great question, and I hate to say it, but again, the answer is both. So what we provide is a baseboard. I call it a feature-rich baseboard, and by feature-rich, I mean lots of different headers to expand into other ecosystems like Arduino, for example, or Click Connect, M.2 connectors. But also on that board then is built in, for example, touch sensing, microphones, speakers, expansion for cameras. So it's a really rich baseboard for some pretty advanced edge-based applications. And then what we've developed is a SOM, actually, that plugs into that baseboard. And on that SOM is the MCU, and it could be the E81, E83, or E84, paired with a Infineon Wi-Fi combo device supporting Wi-Fi 6, Bluetooth, and BLE, as well as off-chip memory for, I'll say rich memory expansion, all on that SOM. So it's the SOMs that really change the processor, but the baseboard is reusable across that range. And what we really, I think, envision here, and I think we see this with a lot of developers, is that there's perhaps a range of kind of good, better, best products, and maybe that good product is cost optimized and really focused on kind of the bare minimum of features for that target application. And if I took as an example a thermostat, maybe it has a segment display, maybe it has some kind of voice command on it, but it's really kind of it's good, it's entry level, and it's entry level price point in the market. And then they want to go to better, and maybe they move to an E83 for that version of the thermostat. Same display, but now instead of just kind of wake and command, maybe they start to enable natural language recognition on that device, so I can talk to the thermostat. And then on the best solution, then they add a GPU, which would be the E84, and they can scale that then to a really rich display on that device as well. But that whole time, of course, reusing their software investment across their portfolio and then scaling the features and costs on the hardware.
That's awesome. And availability?
So we are sampling now these lead devices to what we call alpha customers for the first set of customers. And we are continue to expand the customer pool that has access to those devices and the software associated with them. Full production will be early next year.
Thank you very much, Steve. That was really good stuff. We're going to wrap up here. That was Steve Totosian, the Senior Vice President of Consumer IoT and Industrial MCUs. And I'm Rich Nass with Open Systems Media.